Welcome to the third section of my video on the summer sky. In this section of the video I will introduce you to some interesting objects near the summer triangle. The summer triangle passes directly overhead at the latitudes of the U.S. Depending on when you observe the objects, they may be in the east, overhead, or towards the west. The three stars, though, serve as an excellent landmark to get your bearings. And of course the Milky Way passes through this section of the sky, so it's possible to follow it if you're not sure. Most of the objects I will show you are dimmer and smaller than in the previous section. To see all of the objects you will need a small telescope. The two clusters can also be seen with binoculars. If you're interested in finding these objects on your own, then please consult the charts on my website. If you're unfamiliar with using astronomical charts, then you will benefit from my course on star hopping. This is available on my website or YouTube. The first object we will look at is the open cluster M11. It's located in the constellation Scutum, which is between the summer triangle and Sagittarius. When I find it, I start with Altair, which is the southern star, lower right in this picture. M11 is not in this field of view, so let me shift to another photo that shows M11. This photo shows the Milky Way below Altair, which is on the left. M11 is in a distinctive loop of stars. Start with Altair and trace the Milky Way south to find the loop. The common name for M11 is the Wild Duck cluster. The Wild Duck is one of the open clusters that I like. The bright star in the center of the cluster makes this very distinctive. I'll leave it to your imagination whether this looks like a duck or not. This cluster is nearly 220 million years old, which makes it much older than the Sagittarius clusters described earlier. The cluster contains more than 500 stars visible with a small telescope. This gives it the dense appearance of a globular cluster. It is not. Like the earlier open clusters, this was originally a dust cloud. The vast expanse of time has allowed the dust cloud to disperse. It's estimated that this is 6,200 light-years away. Let's return to the summer triangle again. At the time of this picture, the triangle was in the east. Remember, this group of stars passes directly overhead and is then in the western sky. When that happens, Vega will be on the bottom instead of the top. In the previous section, we talked about how stars formed. Now let's see what happens when stars die. One of the most spectacular examples of what happens is the Dumbbell Nebula, which is Messier Object 27. This is called a planetary nebula, an unfortunate name since they have nothing to do with planets, but William Herschel thought planetary nebulas looked like Uranus, which he had just discovered. The name stuck. Planetary nebula are formed when a sun with a mass less than 8 times the Sun reaches the end of its life. The short description is that the star puffs out its outer layers of its atmosphere. What is left provides an energy source that causes the gas to glow. The full story is beyond the scope of this video, but is explained in detail in the credits for this movie. Of course, if there were any planets revolving around this sun, they were vaporized. M27 is the result of one such star death. The distance to M27 is not known with certainty. Estimates range from 490 to 3,500 light-years, but 1,250 light-years is considered the best current estimate. The physics of this type of nebula cause them to glow brightest in the green color of oxygen 3. Hence, amateur astronomers frequently use a filter that only passes this green light so the nebula stands out better. What if a star is bigger than 8 times the size of the Sun? Those stars have a more dramatic end awaiting them. The next object is an example of this. Between 5 and 8,000 years ago, a large bluish star, about 1,400 to 2,600 light-years away, came to the end of its life. In an instant, it produced a blast bright enough that it will be seen in other galaxies, when the light gets there. The star shredded itself, spewing its debris in a glowing blast pattern. In the process, it created heavier elements. The elements in our bodies are the debris of such an explosion. What was left is more formally called a supernova remnant. The most famous supernova remnant is M1, the Crab Nebula, which was observed blowing up in 1054 AD. The supernova remnant from the Veil explosion now covers a 3 by 3 degree section of the sky. That's 36 times the area of the full moon. It is so large that it was assigned several catalog numbers, NGC 6960, 92, and 95. This photograph is of the west section designated 6960. It's near the star 52 Cygnus. This star is bright enough to see with your naked eye in a dark site. To see this object, you will need to use a telescope with an O3 filter. A scope so equipped will be treated to a view much like what you see in this picture. Earlier we discussed the planetary nebula M27, the dumbbell. Another spectacular summer planetary is M57, the ring nebula. This is located close to Vega between two bright stars, Beta and Gamma Lyra. Like M27, this was formed when a dying star shot off its outer layers. In this case, most of the blast went at right angles to the Earth. Thus we see a clear blast ring, although recent research suggests we are looking into a cylinder instead of a ring. This is by far the smallest object. It's only about 3 minutes of arc across, roughly 1/20th of a degree. You'll definitely need a telescope to see it. Current thinking is that the ring is 2,300 light-years from Earth, but this is an area of active research. The last object we will look at is located in the constellation Hercules. This is west of Vega and the rest of the summer triangle. This photo shows what the constellation will look like after midnight in July. Hercules contains a keystone shape. On the west side of the keystone is located the globular cluster M13. Unlike M22, which is low in the sky in the U.S., M13 passes nearly directly overhead. Thus we are offered a view that is not filtered by a lot of atmosphere. M13's 100,000 stars makes it a bright and easy target for binoculars. It has been reported to be a visual object in pristine skies, probably also requiring teenaged eyes. While M22 is technically brighter, M13 is set off by a dark background and rises higher in the sky. M13 is another member of the globular halo discussed in the previous section. In this case, the object is more than 25,000 light-years away. Its diameter is almost 145 light-years, or 33 times the distance to our nearest star. M13 is an ancient object. The current estimate is that it's 10.9 plus or minus 1.4 billion years old. That would mean that it was formed within the first few billion years after the galaxy was formed, or about 6 billion years before the Earth was. This concludes our look at the summer sky. See my website for additional information on astronomy and for future videos.